Even in my eyes, I will always rise in wildfires. I ain't never been scared, even through my tears. I will always care.
All right. So as I mentioned, going to generate a couple of new lectures relative to the material that we were going to cover in class, but I will be out of town. And so let's jump into that. So what we started on Monday of this week was a conversation about what we refer to as perfect competition. So the idea of perfect competition is that we're going to take this idea of competition and we're going to sort of take it to its logical conclusion. So what happens to specifically firm decision making within the context of a perfectly competitive market? And then what we'll do is we'll sort of take a kind of broader look at what that would then mean for the relative social welfare that arises from markets. One of the ideas that we're really going to get into, especially when we start thinking about different types of market structures, is to what extent do those market structures contribute to what we might refer to as social welfare. So if you think back to this idea that economists think that at any given moment there is a particular sort of social welfare that we can achieve. And then the idea is that markets help us in good circumstances to achieve that particular social welfare. And then we are interested in what happens to social welfare if something changes, right? We've previously discussed this semester, social welfare, roughly speaking, is maximized when we have competitive markets that are equilibrating, supply equals demand. And when we implement policies such as price controls, taxes, and or subsidies, then we move the market away from that natural equilibrating position. And if the market in question was a competitive market, then those interventions theoretically move us away from social welfare. So they reduce social welfare. So it's a really important idea that we're going to talk a lot about for the sort of remainder of the semester, which is to what extent do markets and market decisions and optimizing ideas carried out by consumers and producers, and then specifically with a focus on producers here, to what extent does that contribute or perhaps even take away from social welfare? That's sort of the main existential question ultimately that economists are interested in, is to what extent do markets contribute to social welfare, and where are those instances perhaps where markets, not necessarily policy, but rather markets themselves, perhaps detract from social welfare. And we'll see that when we discuss monopoly power and market power more generally. So again, if we're just looking at these slides here, the idea is that we're going to sort of ask what happens if a market is completely competitive, like perfectly competitive. Now, to the extent that we've defined what a competitive market is, just keep in mind that when we say competitive market, really all that boils down to is firms are price takers. So yeah, we have these four assumptions, and in a sense, it's important for us to know what these four assumptions constitute. But taken together, and the key idea with these four assumptions is that they produce a price-taking behavior within markets. And so firms are not setting prices in perfectly competitive markets. So the sort of main defining feature of a perfectly competitive market is that the firms within it do not set prices. They are price takers. Now, this makes our life a lot easier because ultimately this means that firm decisions just go back to production decisions. So we're sort of thinking about the way in which firms maximize profits in a world where they don't set prices. And in that world, the only decision the firm ultimately makes, broadly speaking, is how much they choose to produce. And we have, very simple math ultimately to define what that so-called optimal production would be. We've talked at length about that being where marginal revenue equals marginal cost. And we'll continue to belabor that point today in this particular lecture as well. So let's just move on and kind of pick up where we left off on Monday. So again, the thrust of this is going to be that we're going to be interested in firm decision making within the context of two key things. The first one is something they do not readily pick, which is the price. They're a price taker, but that of course affects their decision making, right? It's not the case that because the firm doesn't set the price, they ignore price. In fact, the price is still going to be a part of the defining process of how much to produce. The other side, the sort of second component that defines optimal production in the context of the firm decision making is the cost structures. How much does it actually cost the firm to produce the good in question? And then that combined with the price that the market is setting, this is going to define optimal production for individual firms. Now, we know ultimately that means that firms are going to choose a production level where marginal revenue equals marginal cost. And then what we're going to do is we're going to put that into this graphical representation of the cost structures. And it's actually going to enable us to, visualize the profit maximizing production level, but will also allow us, if we actually have the numbers filled in, to calculate profits. And we get a nice sort of geometric visual profit idea, which I think really helps to sort of drive home some of the points that we're making here. So remember, we talked about these two, in particular, the average total cost curve and the average variable cost curve. These are just, data. So when you look at these particular curves, I mean, literally, the idea here would be that the firm, knows how much it costs to produce their product, and therefore, for a given level of production, they're going to know what their total cost would be, and then, of course, for a given level of production and a given total cost, they would be able to determine their average total cost. And the same thing with average variable cost. So these are lines in a graph, but the lines, of course, represent actual data, in this case, hypothetical, theoretical data, that says how much it costs a firm to produce on average in terms of the total cost. And then in the short run, where there is some fixed cost, we're going to see a divergence between average total cost and average variable cost. And so average variable cost is also detailed there as well. And these loom large in terms of importance for the analysis that we're going to carry out in just a moment. Here's just a table of various costs for a hypothetical firm situation. So you'll notice, for example, that this firm has a fixed cost of $100. It doesn't matter how much they produce. They always have to pay that fixed cost of $100. You'll notice that they have here a variable cost, which changes as they produce more. In particular, it rises. And then, of course, fixed cost plus variable cost, that's our total cost. Very sort of simple arithmetic kind of way to think about it. And then what we end up being very interested in is marginal cost. That's the change in total cost as we choose to produce more. And so you should, again, see we went from 150 to 200, and therefore marginal cost is 50, right? And then when we made the third unit, we went from 200 to 250, and that that gave us a marginal cost also of 50, right? So it's just plotting data. So, there can sometimes be an issue with students where they see these graphical representations and they kind of lose sight of the fact that this is just a manifestation of the data. And in case this is a hypothetical firm, Todd's Terrific Takeout, and we're going to say they have these cost structures that are identified by these particular cost curves. I refer to this graphical representation as the cost structure of a firm. It gives you an idea of again, just sort of what the firm's costs are. It's sort of also as simple as, if we think about, this is a perfectly competitive market. So we know that there are a lot more firms in the market than just Todd's Terrific Takeout. And sort of a key idea that we're going to consider is that firms are going to potentially have different cost structures. So there will be higher cost firms and there will be lower cost firms potentially than Todd's Terrific Takeout in the short run. And then there's this kind of interesting sort of economic mechanism that sort of almost magically kind of produces this really interesting outcome, which we'll get to in just a moment. Okay, so now we're going to add into the cost structure the marginal cost curve. I mentioned this on Monday, but I'll say it again, is that just mathematically, it's kind of useful to just kind of put into your head that the marginal cost curve will always, I reiterate, always intersect the ATC and AVC curves at their minimum, just mathematically. And so that ends up being actually an important economic point that we'll make a little bit later, but it's just good to kind of keep that in your head. It'll help a little bit later. So marginal cost intersects AVC and ATC at their minimums. Ultimately, average fixed cost ends up being not a terribly important idea here. It's there in the graph as the vertical distance between ATC and AVC. But as far as like the economic importance of average fixed cost, it's not really much of what will factor into our calculus. Now, fixed cost, as we'll see in a moment, is a really important point into firm decision making. But we're going to enable sort of, you'll see in a moment what I mean, that the actual sort of distance of AVC from ATC, which constitutes average fixed cost, itself is not terribly important. Now, okay, so this is where we really start to get into kind of some newer ideas that we haven't fleshed out just yet. When we think about a competitive market, right? So you see here to the graph to your left, we have a classic supply and demand situation, and that supply and demand is equilibrating here at a market price of $5. Now, if we refer to firms in perfectly competitive markets as price takers, as we do, if we say that firms in perfectly competitive markets are not able to set prices but simply charge the price which is set by the market, then what this essentially means is that the firm faces a horizontal demand curve. Now, what we mean by that practically is a horizontal demand curve would suggest that there is no demand whatsoever above that particular price. So you'll see here at a market price of $5, we say that the individual firm sees a horizontal demand curve at a price of $5. And therefore is, as we've already established, going to charge $5. And then the idea is that because we have many buyers, the assumption of many buyers holds true here, there's going to be a seemingly infinite potential number of sales at that market price. Now, ultimately, because there's many sellers, we predict that competitive firms will not sell a large proportion of the entire market. If they sold a large proportion of the entire market, they would have market power, and we'll find out later on, market power ends up constituting price-setting power. Firms don't have price-setting power here. The way that we illustrate that lack of price-setting power is with the horizontal demand curve. So it can sometimes for students be a little bit weird to consider this idea that firms individually see these horizontal demand curves, but it's simply an illustration, a kind of mathematical illustration of the fact that the firm is a price taker as opposed to a price maker. Now, one thing students sometimes get a little confused here is why does a firm not just simply move the price below $5? You call the firm a price taker, but do they really have to charge $5? This is where the theory starts to strain a little bit some of our logical conclusions. In particular, it is true that if I suspect all of my competitors are going to charge $5 for a product, there's probably a pretty significant incentive for me to charge less than $5. However, keep in mind here that the market price is going to be set theoretically by the profit maximizing behavior of firms. Now, one of the things that we'll see here in just a few moments is that when we take a competitive market into the long run, the profit outcomes have kind of an interesting story and helps to feed back in a little bit into the narrative as to why the firms face a horizontal demand curve. So we'll in fact come back to this idea here in just a moment. So we've already established this semester, firms are going to produce up until the point where marginal revenue equals marginal cost, no more, no less, right? We have the sort of Goldilocks level of production. And so graphically, we can look at this and see that the profit maximizing level of production looks to be a little bit greater than 50 units. So if the firm produces less than 50 units, we can see that marginal revenue is greater than marginal cost, which means the firm should produce more. They're leaving profits on the table. And we can see that beyond 51 units, marginal cost is now greater than marginal revenue, which means that they're losing money at that point. And so if you're producing greater than, say, 51 units, your marginal costs are greater than your marginal revenue, so you should reduce your production. If you're producing less than 51 units, your marginal revenue is greater than your marginal cost, and so you should produce more. The key idea here is that our assumption is going to be firms always produce where marginal revenue equals marginal cost. In the real world, we might imagine that this is something that firms don't do perfectly, that firms might sort of not always get this exactly correct. In our theoretical model, we're going to assume the firm is able to know exactly what production level will achieve marginal revenue equal to marginal cost. And this is just sort of a graphical representation to kind of wrap your head around that particular idea. Now, the other, of course, really important point is that the marginal revenue curve here is just the market price, is just that horizontal demand curve that we saw here. In fact, I've labeled it here as marginal revenue. We have previously established that in a situation where the firm is a price taker, that they just charge whatever the market price sets. Since marginal revenue is the change in total revenue when I sell an additional unit, that has to be the price. And so therefore, in competitive markets, we have a nice simplification, which is that the market price ends up just being the marginal revenue for all of the firms in that particular market. And so when we see the marginal revenue curve here in this particular graph, that is just the market price. And so we can sort of shortcut a little bit here, and beyond saying marginal revenue equals marginal cost, we can also say that firms in a perfectly competitive market are going to produce up until the point where the price they're charging is equal to the marginal cost, because the marginal revenue is the price that they're charging. And so MR equal to MC in the context of a perfectly competitive firm means price. P star is also equal to MC. Okay, now let's kind of do a bit of a numerical example here and sort of illustrate these particular points. So in the graph to the left, this is the supply and demand of a particular market. It looks like we have tracksuits. So Todd's Terrific Tracksuits, a different firm in the tracksuit market. And we can see that the tracksuit market is producing at a market price of $70. Firms are price takers, and so firms are going to charge $70. So now in the graph to the right here, this is an individual firm, right? So this is an individual firm's cost structure. But all we're going to do is we're going to take this market price of 70, and we're just going to take it across to the right here, and we're going to establish that as also the marginal revenue. So marginal revenue is 70. At this point, all we have to do is see where marginal revenue intersects marginal cost, and then take that straight down, and that's going to give us the profit maximizing production level for the firm, which we can see here at a market price of 70 is equal to 58 units. So this particular firm maximizes profits only by producing it at a level equal to 58. If they produce 57, they make less profits. If they produce 59, they make less profits. They maximize profits at 58 units produced when the market price is 70. Now, if this was a different firm, and if that different firm had different cost structures, higher costs, for example, then this same outcome is going to produce a lower quantity decision for the firm, because if they have higher costs than this firm, then for the same market price, again, they're still price takers, that firm is going to produce less as a result. Whereas if there's a firm that has lower cost than this particular firm, then that firm is going to produce more than 58 units, which should seem fairly logical. Now, the other thing that we can do here is we can actually visualize and then ultimately calculate profits. And so what we can see here is that at a market price of 70, the firm is going to produce 58 units. Well, that means we know what total revenue is, because total revenue is just price times quantity, right? And so here we can see that the market price is 70. We can see that the firm is going to produce 58 units. We'll assume here that because ultimately this creates a supply equals demand scenario, everything that gets produced also gets consumed. Just a really simple assumption we're going to make here. It makes our life a lot easier. So the firm is going to sell 58 units. They're going to charge $70 for those 58 units. And so therefore total revenue ends up just being this rectangle that we see outlined here in blue. So 70 times 58. And so we can calculate total revenue for the firm here. It's just price times quantity. We know what the market price is. That's set by the market, $70. We know what the profit maximizing quantity is for the firm because we took that market price of 70. We took it straight down from its intersection with marginal cost, and we can see that the profit maximizing level of production was 58 units. So let me just grab a notepad here. And this here. Okay, so let's just real quick. Sorry, I got this. Some of my research stuff here is okay. All right. So, oops. There we go. Let's do that. Save. Okay. So as we said before, we have a market price of 70. We have a profit maximizing level of production of 58. And so we're just going to say profits are equal to price times quantity. That's just total revenue. And then minus total cost. Okay. All right. So we know the first part of this. We know that profits for the firm are going to be equal to 70 times 58. And then how do we find total cost? Well, to find total cost, we just want to remember that average total cost is just equal to total cost divided by Q, how much the firm actually produces. And so if we go back to the graphical representation for a moment, we know we have ATC. And in particular, we know that at a production level of 58 units, that ATC is 56, because all we have to do is take 58 units, take it up to the ATC curve. Remember, that's just data. That tells us what the average total cost is at that particular level of production. So at a production level of 58, we can see that average total cost is $56. Well, again, remembering that average total cost is just total cost divided by Q, we can solve this for total cost, and we get ATC times Q. Okay, that means that profits here, we can change total cost here to just be ATC times Q. Same thing as total cost. And so if we look at our graphical representation here, we can see that, again, at a production level of 58 units, we get an average total cost of 56. And so therefore, total cost is just going to be the ATC of 56 times the 58 units of the profit maximizing level of production. One key thing to keep in mind is that when you calculate profits, the production level should be the same across the two, the total revenue and the total cost, because that's going to be the profit maximizing level of production. It's one thing to kind of check your work there to make your life a lot easier. Okay, so at this point, profits are pretty easy to calculate. I'm just going to take the difference between 70 and 56 and then multiply that by 58. So 14 times 58. And we can do a quick little calculator, cheat a little bit here. So 14 times 58, we get a profit of $812. So for this particular firm, if the market price for their product is $70. They're going to produce 58 units. At those 58 units, that gives them a profit equal to $812. Right? Very, very straightforward. The key here is just that you know where to look on the graph, right? You remember that marginal revenue equals marginal cost in the context of profit maximization. You remember that total cost is equal to average total cost times Q. So all you got to do is find that profit maximizing Q. You already know what the market price is because you couldn't have found the profit maximizing Q without knowing the market price. So total revenue is just P times Q. And then to find total cost, we just find the average total cost at that profit maximizing level of production, and then multiply that by ATC. And then again, total revenue minus total cost. And we get here a profit outcome for this firm of $812. So what this means is that under current market conditions, the current market conditions are that the price is 70 units. And at this firm's current cost structures, this firm earns a positive profit of $812. Okay, so I'm going to cut it here. And then in the next video, I'm going to extend this example. And what we're going to do ultimately is we're going to ask ourselves, what changes as we move from the short run into the long run? Okay, so if we just, again, look at this graph here to the right, we know this is the short run because ATC and AVC are not equal to each other. And the distance between ATC and AVC is average fixed cost. So there's fixed cost here. And because there's fixed cost here, we know this is the short run. So right now, in the short run, this firm is earning profits of $812. But markets change. Firms enter markets, firms exit markets, equilibriums change, the market price changes. And so one of the things we're going to be interested in is what happens to firm decision-making in a world where prices might be changing. And then more importantly for us, what happens in this world when we move our analysis into the long run? And what we'll find is that when you move your analysis into the long run, you get this really kind of interesting, perhaps counterintuitive result. But that result is sort of foundationally important to virtually the entire notion of microeconomics. And so I don't want to spoil it too much. And so we are going to cut it there. So I'll see you in the next video.